Okay, if you've ever spent any time on a Linux system, you know the feeling. You're having a great day, things are getting done, and then your entire workflow just grinds to a halt because of two little words. Well, in this explainer, we're going to take that frustration and turn it into a deep understanding of how Linux security actually works.
I mean, seriously, think about it for a second. You're trying to run a simple script, maybe check a log file or just cd into a directory, and the computer just tells you, nope. You know exactly what I'm talking about, don't you? It's this one. That's it, 2 words. But here's the thing. Those 2 words aren't just a random error. They're a symptom, a clue that we're misunderstanding a security model that's actually, believe it or not, surprisingly simple. And by the end of this, you're going to have the key to unlocking it for good. So where does everybody go wrong? What's the biggest mistake we all make? Well, it's not what you think. The problem is almost never with the permissions on the file itself. It happens way before Linux even gets around to looking at it. It all comes down to something called the permission hierarchy. And you know, the idea is actually really simple. Think of your entire file system like a house. You might have the key to your bedroom door, right? But if the front door of the house is locked and you can't get in, who cares about your bedroom key? It's useless. Linux works the exact same way. Before it even bothers checking the permissions on your file, it checks if you have the key to get through every single door, every directory on the path to get there.
So let's really see this in action. To get to run.sh, Linux has to take a walk. It needs the execute permission, which for a directory really means traverse, to get into slash, then slash home, then slash shared, and so on. If at any point it hits a locked door, like the slash shared directory here, it just stops. That's it. It doesn't matter that slash project is wide open or that you have perfect permissions on run.sh. Game over. This right here, this is the secret behind almost every permission denied mustery you've ever had.
Okay, so let's say we can actually reach the file. We made it through all the directory doors. Now what? Well, now Linux needs to figure out who you are. And it does that by checking you against 3 possible identities, or actors, in a very specific order. See, Linux has this really strict checklist. First up, it asks, are you the owner of this file? If the answer is yes, it applies the owner permissions, and the check is completely over. It doesn't look any further. If you're not the owner, it moves to the next question. Okay, are you in this file's group? If yes, you get the group permissions, and again, the check stops right there. Only if you fail both of those checks do you land in the others bucket. It's a first match win system, always. And this is how it all fits together when you see that, that wall of text from the ls-l command. That string of letters and dashes isn't just random noise. It's a map. The first set of 3, rw-, that's for the owner, Alice. She can read and write. The next 3, r-, are for anyone in the dev team group. They can only read. And the final 3, r-, that's for everybody else. It's a perfectly logical breakdown.
So now we've got the nuts and bolts down. We know the mechanics. But what's the philosophy? What's the big idea that turns these commands from just a chore into a real professional security practice? Well, that's what we're going to call the doctrine of security. This one rule, this single idea, changes everything. It's the principle of least privilege. You always start with the most restrictive permissions possible. Only the owner can do anything. Then, if and only if a team needs to collaborate, you carefully open it up to the group. And that others category, you should almost never give permissions to others unless something is truly meant for the entire public. This simple doctrine just wipes out a whole class of security problems.
And when you think that way, all of a sudden the tools just click. You use chgrp to change the group because you need to do some controlled, limited sharing. Perfect. You use chmod to sculpt those permissions down to the absolute minimum needed. And umask, that's your strategy for denying permissions by default. And that notorious chmod 777, it's the total, complete opposite of this doctrine. It's throwing the keys to the whole kingdom out on the street. So, with the why, our doctrine, firmly planted in our minds, let's get our hands dirty with the how. These are the tools of the trade, the commands you'll use to put that security philosophy into practice. The main tool in your belt is chmod, and there are really 2 ways to use it. On the left, you've got symbolic notation. It's awesome for learning because it reads like a sentence. For the user, add the read permission. Super clear. But what you're going to see out in the wild, the industry standard, is the octal notation on the right. It might look a little cryptic at first, but it's built on incredibly simple math.
Don't let the word octal scare you. This is literally all you have to remember.
Read is 4, write is 2, execute is 1. That's it. You just add the numbers together for the permissions you want. So if you need read and write, 4 plus 2 equals 6. Need read and execute, 4 plus 1 is 5. Need all 3? 4 plus 2 plus 1 is 7. So when you see chmod 644, it just means the owner gets a 6, read-write, and the group and others both get a 4, read-only. Simple as that.
All right, let's tackle the single most misunderstood command in this entire toolkit, umask. The mistake pretty much everyone makes is thinking that umask sets or grants default permissions. But the truth is the exact opposite, and it lines up perfectly with our security doctrine.
Here's the big reveal. Umask is a tool for denial. It doesn't give permissions, it takes them away. The system starts with the idea of giving full access, and your umask value is a mask that specifies which of those permissions to block, to subtract, right when a new file is created. It's security by default. You start locked down.
So let's look at a super common one for the root user, 022. That first 0 is for the owner. It means we deny nothing from the owner's permissions. The next 2 2s are for the group and for others. A value of 2 means we deny the right permission. So whenever root creates a new file, it will automatically be read-write for root, but only read-only for everyone else. It's a default security policy, built right in. And now, let's talk about the ultimate violation of everything we've just discussed. This quote from the source material really says it all. Running a command like chmod -r777/ recursively gives everyone permission to do everything to every file on your system. It is not a quick fix, it's an act of self-sabotage.
Okay, let's bring it all home. We're going to tie the permission hierarchy and the security doctrine together with a few common real-world examples. This is how you actually apply this philosophy day to day.
Look at how cleanly these follow the doctrine. For a shared document, you want the owner and the group to be able to write, but everyone else can only read. That's 664. For a script that lots of people might need to run, the owner can edit it, but everyone else can just read and execute it. That's 755. And for something really sensitive like an error log, 600, only the owner can see or change it. Minimum necessary privilege every single time.
And that brings us to the final unifying idea. If you walk away with just one thing today, let it be this mantra. First, control the path. Make sure you have access to all the directories. Second, control the object. Set the right permissions on the file itself. And the rule for both? Deny everything you don't explicitly need to allow. This is how you stop fighting permission denied and start building a truly coherent security strategy.